Here's section 3.2. It's called linear functions. And all we're going to do is, you can recall back in chapter 2, we worked with y equals mx plus b. That was slope-intercept form. And we had an x variable and we had a y variable. The only thing that we're going to change today with functions is, instead of writing it in what we would consider a standard notation, is we are going to put it in what's called function notation. Okay, function notation just takes the y out of it and it replaces it with what's called f of x, is how I would read that. It says f of x equals mx plus b. We still have a slope. Okay, we still have the slope of the line. We still have a y-intercept in our function notation. The only thing that I've done is I've taken out the y variable and I've replaced it with an f of x. And that f of x is just a different way to write it. X is still the input values. You're still going to be plugging values in for x, and this is going to still be your output values, but instead of y, it's going to be f of x. And again, we read that as f of x. So f of x equals mx plus b. Here's an example of a linear function. I would read this as f of x equals 5x minus 1. That slope of that function is 5, so it's going to rise 5 and run 1. It's going to start at negative 1 on the y-axis. Okay, none of that changes from topic 2. It says, what is the value of g of x equals 5x plus 1 when x is equal to 3? So what you're going to do is you're going to say g of 3. This just means that I'm going to take that 3 and I'm going to plug it in for x. It equals 5 times 3 plus 1. Now what gets confusing for kids is that there's nothing to evaluate over here. This is just the name of the function and that we're plugging in 3 for x. The only thing that we evaluate is to the right side of the function. 3 times 5 is 15 plus 1. So we'd say that this is going to equal 16. It says evaluate each function for when x equals 4. So again, you're going to take that g function and you're going to replace the x with a 4. Okay, you're going to plug that in and you're going to say negative 2 times 4 minus 3. There is nothing to evaluate over here. This does not mean g times 4. This is just function notation. G of 4 equals. I do the math on the right side. So I'm going to get negative 8 minus 3, and that equals negative 11. Okay, same thing. This is a different function. This is h of x. So I'm going to say h of, we're still plugging 4 in for x, so h of 4 equals 7 times 4 plus 15. Okay, again, there's nothing to evaluate over here. That's just the function name and that we're plugging 4 in. 7 times 4 is 28 plus 15. We say the value of h of 4 is, we add these together, and I get 43. Okay, now, this is where it gets a little confusing. So it says, what is the value of, and then it says f of negative 3 if the function is this. Now, this is not telling you to plug in a certain value for x like it did up here. It's telling you the value of the function, f of negative 3. So this is your plugging in on the left side. Okay, you're going to say f, or actually, let me ask you, what is the value of, what did they plug in for x? That's what I'm going to ask you. What did they plug in for x here? Well, negative 3 went in there. So I'm going to say f of negative 3 equals, this is what they're telling you to plug in. Okay, that's what they're telling you to plug in. So you're going to say negative 12 times negative 3 minus 7. Negative times a negative is positive 36 minus 7. I get a value of 29. So the value of f of negative 3 is 29. Okay, it says writing a linear function rule. The rule is to come up with your equation. Okay, so just like before, we're going to be writing equations and we're going to do it in slope-intercept form. Okay, but now instead of a y equals, we are going to be putting f of x there instead of the y. But we go about finding the function the same way that we did in topic 2 for the equation. So we need to know our slope and we need to know our b value. And all you need to do is pick out 2 points out of this table. So I'm just going to use the first 2 points. Okay, you don't have to use the first 2 points. You could use any 2 of those points. but I'm going to say one point is 1, 6.5, and the other point I'm going to use is 213. Okay, and just like from topic 2, how would you go about finding the slope given those 2 points? Well, we still find slope the same way. Take y2, and we subtract y1. We divide it by x2 minus x1. Okay, 13 minus 6.5 is 6.5 over 1, which is just 6.5. So that is your slope. And then you've got to find the b value. So I would say y equals mx plus b. How did we find b in chapter 2? Well, we took and we plugged our slope in. So we found our slope to be 6.5. I'm going to plug that in. And then to find the b value, I'm just going to choose a point and I'm going to plug it in. I'm going to take this point and I'm going to plug that in. My x value is 1. And my y value is 6.5. Okay, I do the math. If I subtract 6.5 from both sides, I get 0 for a b value. So here's my b value and here's my slope. So my function, and the only difference is from chapter 2, is you want to write your answer in function notation. So rather than saying y equals, you're going to say f of x equals, you're going to plug in your slope, x, and then your b value, plus 0. Now if it's plus 0, you don't need to write it, but if you want to see slope and your b value in your function, then you would put in there plus 0. Okay, let's try another one of those. So from my table, I'm just going to select any 2 points. So I'm going to use 1, 1, and you don't have to use the second point. Let's use 3, 7. Okay, but you're going to select 2 points out of that table, and we have to find our slope. So slope is going to be 7 minus 1 over 3 minus 1. So this would be 7 minus 1 is 6 over 2. My slope is 3. And then to find my b value, I'm going to use the second point here. So I would say 7 equals my slope times my x value plus b. 7 equals 9 plus b. If I subtract 9 from both sides, I get negative 2 equals b. So if I'm writing it in function notation, I would say f of x equals my slope and then my b value. And that would be my function. So you're doing the same thing that you did in chapter 2. You're just putting it in function notation. Okay, example 5 and example 6 here. Example 5, it says Tamika records the outside temperature at 6 a.m. At 6 a.m. we're going to say that's 0 hours have passed, and the outside temperature, let's see, Tamika records the outside temperature at 6 a.m. and you can see at 6 a.m. it's at a negative 3. Okay, and then it says the outside temperature increases by 2 degrees every hour for the next 6 hours. If the temperature continues to increase at that same rate, what will be the temperature at 2 p.m.? Okay, they want us to write a function that models that. So again, we want the slope and then the b value. Well, if you think about the slope is the rise and the run. The slope is the rate of change. So how is this temperature changing every hour? Okay, well, it's increasing by 2. So f of x is going to have an increase of 2. It's going to rise 2 and run 1. And then the b value is where it crosses the y-axis. Where did it start? At 0 hours, before any time had passed, what was the temperature? What was the starting temperature? Well, we could read the graph here. It was at negative 3. So my rule or my model or my function is going to be f of x equals 2x minus 3. It says use the equation to solve the question. What will be the temperature at 2 p.m.? Well, how much time has passed from 6 a.m. to 2 p.m.? How much time is that? That's a total of 8 hours. So I'm going to plug 8 hours in. I'm going to say 2 times 8 minus 3, and technically we're plugging that in. So we're saying, what's the function after 8 hours? And we get 16 minus 3, and that's equal to 13 degrees. Okay, so it's going to be 13 degrees Fahrenheit at that time. Okay, linear function is a function whose graph is a line. When you're sketching the graph, we're going to do the same thing that we did in topic 2. When we graphed y equals mx plus b, where did we start on the graph? Well, we started with whatever the b value was. That was the y-intercept, right? Same thing here. Okay, the y-intercept is your positive 1, so that's where I'm going to start. That's my first point. And then what's the slope of that line? What's the value in front of x? The value in front of x is negative 1. So if I make that into a fraction, that tells me I'm going to go down 1 and to the right. And there's your function. There's your linear function. It's the graph of a function. Okay, in example B, where are we starting? Okay, well this is also a plus 1. That's just a coincidence. It's not always going to be plus 1. But this time, what's the slope of that line? This time the slope is 3. So if I make that into a fraction by putting a 1 under it, I'm going to rise 3 and run 1. Rise 3, run 1. Or I can go down 3 but left 1. Okay, there's my function. And again, just like before, the slope here is positive. That's an uphill. You're going uphill. It should be positive. Or actually, since it is positive, you should be going uphill. And then this one's negative. So your line should be going downhill, and it is. Take some time to check those things out. Make sure you've got the right line graphed. Okay, go ahead and find worksheet 3.2 and give her a shot.